Okay, welcome back to my YouTube channel. So in this video we'll be considering another example on trigonometric Fourier series. So this is continuation of the previous video. So if you haven't watched that video, so please go and watch it, check it in the playlist. So this question is similar to the previous one. The only difference is that there is the interval has been changed to minus pi from 0 to 2 pi to minus pi to pi. So we are still going to solve it in a similar fashion, but the values of your constants will be different. Alright, so when they say we should obtain this function using the Fourier series expression, so we know they are talking about this 1 over 2 a naught plus summation n equals 1 to infinity of an cos nx plus bn sin nx. So your a naught is 1 over pi from minus pi to pi of f of x dx. Your an is still 1 over pi from minus pi to pi f of x cos nx dx, and then your bn is given as 1 over pi minus pi to pi f of x, then what, sine nx dx. Alright, so let's evaluate each of them. So consider the one of a naught is 1 over pi from minus pi to pi. F of s is s squared, they gave us to be s squared in the question, then ds. So evaluating that integral, we get s cubed over 3 from minus pi to pi. So you write your minus 1 over pi outside. So putting your pi, you get pi raised to power of 3 over 3. So minus into brackets. Instead of using pi, we use minus pi next. So get minus pi raised to power of 3 over 3. So let's evaluate this. Get 1 over pi over 3 over 3 minus, this will give you minus pi 3 over 3. So that minus with times to give you plus. To give you plus pi 3 over 3. So the denominators are the same, or if you do LCM, so you get pi 3 over 3 pi. So pi are common. If you cancel, you get pi 2 over 3. Pi raised to power of 2 over 3. Oh, sorry, I missed out the 2. When you add the top, there is a 2. So you get 2 pi raised to power of 2. Sorry. If you add the pi cube and pi cube, you get 2 pi cube. Alright, let's go to an. So an is 1 over pi. Integral from minus pi to pi. F of s is s squared. Then you have cos nx dx. So to solve this, we need to know the integral of this guy. So using the DI method, we use the DI method here. So how does the DI method works? So let's say DI. Pretty simple. All you only need to do is the s squared is the one you differentiate, while this other one is the one you integrate. So if you differentiate this, you get 2x. Differentiate this, you get, differentiate cos, you get sine nx over n. Differentiate this, you get 2. Integrate this, you get minus cos ns over n squared. The last time you get 0. Here you get minus sine nx over n cubed. This is plus minus. So you cross multiply. So we have minus s squared cos nx dx. So the sign with times, this is plus, so that would be s squared sine nx over n. Minus times minus will give you plus, you get 2s cos nx over n squared. And the last one, plus and minus will give you minus, you get 2 sine nx over n cubed. So please pay attention. an is equal to 1 over pi from minus pi to pi of s squared cos nx dx. This is what we want to integrate. Now we've gotten the integral, so you put it here, sin nx over n plus 2s cos nx over n squared minus 2 sin nx over n cubed from 0 from minus pi to pi. So you get an is equals to 1 over pi. So if I put pi now, I'll get pi raised to the power of 2 sin n pi over n plus 2 pi cos n pi over n squared minus 2 sin n pi over n cubed. You open a bracket, you do the same thing. Minus, you put on that bracket, you do the same thing, but this time around you put minus pi in place of all the x that you see. So for the first one, we get minus pi squared, then sin n pi over what? N minus pi, sorry. Then we get plus 2 minus pi cos n minus pi over n squared minus 2 sin n, then minus pi over n cubed. Okay, so I opened a semi bracket here, so I closed it, but there is a bracket I opened initially, so I closed the bracket here. So what do we do next? As I told us before, as long as there is a pi, see pi here, see pi here attached to the sign, all those guys will give you 0. Okay, so now as long as there is a pi attached to the sign, whether negative pi or positive pi, they all give 0. So that one will reduce your work. So all those guys are 0. So what is left is 2 pi cos n pi over n squared. So that is the only thing here. So here we have a minus, you have a semi bracket, and then you have 2 minus pi, and then you have cos n cos n into brackets minus pi over n squared. So you close your brackets. So you have an is equal to, so let's open that bracket now. We have 2 pi cos n pi over n squared minus, this will give you minus 2 pi cos n minus pi over n squared. So this will give you plus 2 pi cos n minus pi. Sorry, there is a minus here. I do video. I don't know why you no close the door. They disturb me. I'll come the edit now. I'll spoil my life. How far now? I just did okay. I don't go pass myself. That's how I want to edit here. Why everything can't look correct? Okay. I shouldn't get the exam tomorrow. So I did do video for them. Let me close the door because of the noise. kind bracket come dey here again?
You go church.
We don't do online service. 1 hour for winners. And daddy preach. I don't jot down, so God don't answer prayer like that. Allow to bomb this video on Monday again. Okay, so here, so we have n minus n into minus pi over n squared. Now, something is going to happen at this point. There is something you need to know. You need to know that, see, cos function, they are very special. If I have cos minus s, this is the same thing as cos s. Like, it's going to, cos will swallow the minus. But if it is sine will not swallow it, will vomit it out. It is a sin. See, it is a sin for sine to swallow the minus. It's going to vomit it out. But for the cos, it will swallow it because it's already a cos. It has been cos, so it will always swallow it. You understand? So for this guy, the cos is going to swallow that minus because it's a cos. It will now be 2 pi, so it's a cos now. So this guy will now be cos n pi over n squared. So what do you observe? You will discover that the terms inside the bracket are now the same. You can now do summation. So you get, you can now add the numerators. Coordinators are the same. So if you add the numerators, you just get 4 pi cos what? N pi. Now, there is another story we are going to tell at this point. You see this cos that is here, this cos n pi, it has a certain behavior for a given value of n. So let's say, for example, n is 1. What will your cos function give you? Cos will give you, you can even draw a table to study the property. See, cos n pi. So when, sorry, maybe I should do it at this top corner. N and then cos n pi. So when n is 1, cos will give us minus 1. When n is 2, cos will give us 1. When it is 3, minus 1. When it is 4, we get what? 1. So it is because of this, we now observe that the cos n pi has the same behavior as minus 1 raised to the power of n. Do you get? Cos n pi has the same behavior as minus 1 raised to the power of n. So we are going to change. Let me remove all this. So we are going to change the cos n pi to minus 1 raised to the power of n. So we get 1 over pi, then we get 4 pi raised to the power of minus 1 raised to the power of n over n squared. So pi cancel pi, you will get 4 minus 1 raised to the power of n over n squared. Alright, so that is the value of an. Now let's go to bn. Bn is 1 over pi, integral from minus pi to pi. F of s is s squared sine ns ds. So we are still going to use the di method to evaluate the integral of sine nx dx. So how does the di method works? So you do the d and then you do the I. So we have the s squared, we have the sine n squared ns. Differentiate this guy, you get 2s. Integrate this, you get cos ns over n. I think it's even minus cos that. So there is a minus sign here. Differentiate this, you get 2. Integrate this, you get sign. Cos doesn't change. You just get n squared. You do it for the last time. Differentiate this, you get 0. Here we give you plus cos nx ns over what? N cube. So you put plus minus plus minus, this times this, this times this, this times this. So s squared sine nx ds is equal to s squared minus, plus times will give you minus cos nx over n plus minus times plus will give you plus 2s sine nx over n squared, plus times plus will give you plus, then get 2 cos nx over n cube. Alright, so let's go back to where we are coming from. 1 over pi integral from minus pi to pi s squared sine nx dx. 1 over pi, so you open your bracket, you write all what you've gotten, cos nx over n plus 2s sine nx over n squared, then plus 2 cos nx over n cube from minus pi to pi. So now your bn is equals to 1 over pi, so you insert pi first. So here there is a minus s squared. The s squared does not cover the minus, so you leave the minus out, just take the square like this, then cos n pi over n plus 2 pi cos sine, I don't know why I write cos, sine n pi over n squared plus 2 cos n pi over n cube minus into bracket. You do the same thing, but this time around you put minus pi. So we have minus pi squared cos nx cos n minus pi over n plus 2 into minus pi sine n minus pi over what? N squared. The last one, 2 cos n minus pi over n cube. Alright, so your bn now is equals to 1 over pi. Now you have and now I told us whenever there is a pi attached to the sign, you get 0. So this 2 has given us 0. Write what is left. Cos n pi over n plus 2 cos n pi over n cube. So if you use minus to open this, okay, hold on. This will give us minus pi squared because of this. If you do this 1 squared, you get pi squared. Because of this minus, there is additional minus left. And cos is a function that swallows minus, so you just get cos n pi over n. It will swallow that minus. Sine will give you 0, and then you get plus 2. Here too, it will swallow the minus, you get cos n pi over what? N cube. Okay, so from here, 1 over pi, let's open that bracket. So we get, if you open this bracket, you get plus pi squared cos n pi over n. Here you give you minus 2 cos n pi over n cube. So that is it. So now, looking at the bracket closely, you see that this term and this term, they are the same. The only difference is the sign. This is negative, this is positive. They will cancel themselves. The other one too, this is plus, this is minus. They are also the same. They will cancel. So at the end of the day, you get 1 over pi times 0, which is 0. So bn becomes 0 like that. So we are done. A naught is what? 2 pi squared. I think 2 pi squared over n. Let's check. A naught, 2 pi squared over 3. 2 pi squared over 3. What about an? So checking again, an is 4 into minus 1 raised power of n over, I don't know what is under it, over n squared. How about bn? Bn is 0. So let's go to our question. We are done. So go back to the main question. A naught plus summation n runs from 1 to infinity of an cos nx plus bn sine nx. Okay, so now replace them. F of s is s, 1 over 2. A naught is 2 pi squared over 3 plus summation n runs from 1 to infinity. An is 4 into minus 1 raised to the power of n over n squared, and then you get cos nx. So the b part is 0, so everything becomes 0. So at the end of the day, the 2 cancel 2, you get pi squared over 3 plus summation n equals 1 to infinity of 4 into minus 1 raised to the power of n over n squared cos what? Ns. If you like, you can still simplify it further by bringing out the 4. Summation n equals 1 to infinity. That is if you like. I didn't say it's compulsory. Then cos nx. So that is all.